All right, so the next lesson is kind of a continuation from the last one, where we're going to look into deductive reasoning. Okay, so remember from the last lesson, just a little bit of review. There's two types of reasoning, all right, inductive and deductive reasoning. Inductive reasoning is when we come up with a conclusion or a conjecture based on observation. All right, and then what deductive reasoning is when we actually prove that it's true for all cases. All right, so actually, I'm going to start off with a little bit of review from last lesson. Let me just get the pen ready here. So first off, I wrote up for these math equations, and what we're going to do is we're just going to use inductive reasoning first to come up with a conjecture. Based on the following equations. Okay, so I got 5 times 3 is 15, 1 times 9 is 9, 1 times 5 is 55, 7 times 9 is 63. Okay, so this time we're going to be multiplying. So notice here that I have odd times odd is odd. Okay, so the conjecture, and again, conjecture is the same as a conclusion. So I'll put that in brackets. Okay, so these mean the same thing. Conjecture is an observation, or sorry, a conclusion that we come up with based on observation. All right, so notice that all 4 of these, I'm multiplying 2 odd numbers together, and the result are odd numbers. Okay, so the conjecture is odd times odd is equal to odd. All right, so this process, what we just did so far, is called inductive reasoning. And again, inductive reasoning is when we come up with a conclusion or a conjecture based on observation. All right, so now on to today's stuff. Is what I'm going to do now is I'm going to prove this is true. Okay, so this conjecture is true for all cases, and that is deductive reasoning. Okay, so we're going to use deductive reasoning to prove that the conjecture is true for all cases. All right, so I want to show that odd times odd is odd. All right, so just a little bit of warning. You may have to watch this example a couple times. Totally normal, because I'm going to use algebra to actually prove this. All right, so yeah, it may seem a little bit odd the first time you see it. That's totally normal. So I'm going to do my best here to explain how to actually prove it. All right. So first thing here is that I want to prove that the product of 2 odd numbers is odd. Okay, so what I'm going to start off with, so we'll call this the proof, is I'm going to introduce a couple variables. Okay, so I'm going to let x and y be, and I want to be specific here. I want them to be integers. Okay, and I'll explain why in a second. All right, but just a little bit of a review. Integers. Let's pull up a different color pen here. So integers are, again, let's go dot, negative, right? So -2, -1, 0, 1, 2, 3, and so on. Okay, so again, integers are basically positive and negative non-decimals. Right? So you cannot have a decimal. Right? So these would be integers, right? All the way from negative infinity, but just going up by 1, -2, -1, 0, 1, 2, and 3, and so that pattern continues. Okay, so those are integers. We want, and basically what I'm doing is I'm assigning x and y to be integers. All right, so once I've done that, I can also conclude that then if I take the first one and multiply it by 2, so 2 times x, and I take the second one, second integer, and multiply it by 2, it's 2 times y. These are both going to be even. Okay, so the reason that they're both even is because no matter what, if I take any one of these integers and multiply them by 2, again, I just want to grab a red pen here. So if I take this number here, multiply by 2, I'm going to get -4. Take this one, multiply by 2, I get -2. 0 times 2 is still 0. 1 times 2 is 2. Then I got 4, and then 6, and so on. Okay, so you can see here that, yeah, well, as soon as I take any integer multiplied by 2, these are both going to be 2 times x and 2 times y, or both have to be even. Right? So this is even, and this is even. All right, but this proof that I'm working with involves 2 odd numbers. Okay, so to make an even number odd, I have to add 1, or I can actually subtract 1 to either one. Okay, so if 2x and 2y are both even, then 2x plus 1 and 2y plus 1 are both odd, right? Which makes sense, right? If I take an even number and add 1, it's going to turn it odd. So this is how we actually create odd numbers with variables. And since we're using variables, x and y, this basically covers all odd numbers when we have 2x and 2y. Okay. All right, cool. So therefore, if I take these 2 odd numbers, so if I take 2x plus 1 and multiply it with 2y plus 1, this is actually the product. So I'm going to actually write p equals. Okay, so this is what I want to prove, is that when I multiply 2 odd numbers, I want to show that this actually turns out to be odd. Okay, because that's the conjecture that I want to prove. Right, so odd times odd is odd. Okay, so again, first step here is just to create our expressions for 2 odd numbers. And then what I'm going to do is multiply the 2 odd numbers together, because that's what I want to prove. Okay, so 2x plus 1, 2y plus 1, I'm going to multiply those together. All right, so hopefully this makes sense so far. All right, so now going back to your previous math classes, and hopefully you learned how to expand out the brackets, or in other words, FOIL. What I'm going to do is actually expand out the brackets. So 2x times 2y, 2x times 1, 1 times 2y, 1 times 1. Okay, so I'm going to FOIL. So first outside, inside, last, FOIL out the brackets. All right, so when I do that, p is going to equal, okay, so 2x times 2y is 4xy. Then I have 2x times 1 is 2x. 1 times 2y is 2y. Then 1 times 1 is 1. Okay, so I expanded out the brackets, and I get this expression here. All right, so I want to show that this is actually odd. Now, some of you actually may see that it actually already is odd, right? Because you can see that there's a plus 1 at the end, and I have 4 times this thing, plus 2 times this thing, plus 2 times this thing. Well, if each one of these expressions is even, when I add them up, I'm going to get even number. Then I add 1, right, to make this whole thing odd. All right, so I just kind of verbally said what the plan was. Now, to actually, another way that we can actually show that this is, like this first part here is even. So let me go put let's grab a different color here. So like if I show that this thing here, these first 3 terms, when I add them together is even, then if I add 1, the whole thing is going to be odd. Okay, so I want to show that this is even. Now, the way I'm going to do that is I'm actually just going to factor out a 2 out of the first 3 terms. Okay, so if I do that, a 2 bracket, 2xy, oops, 2xy, okay, so I'm factoring out a 2 here. So I got 2 times 2xy plus x plus y, and then I have the plus 1. Okay, so what I did there is I pulled out a 2 out of the first 3 terms. I get this, and you can see that 2 times, this whole thing is an integer. That makes this whole thing even, plus 1. All right. So here I'm just going to put p equals. All right, so we know that this expression is even because I'm multiplying the bracket, the stuff inside the bracket by 2. Okay, so I'm just going to write even plus 1. And so therefore the product is, if I take an even number, add 1, it's odd. Okay, so since I have this plus 1 left over, even plus 1 is equal to odd. All right, so this is a proof that shows that the product is odd. Now, yeah, so, and again, if you got to watch this or go through this example again, it's totally normal. All right. I remember that actually the first time I learned this, it took me a while to actually get my head wrapped around all this concept. It's very, I would say, abstract thinking, but hopefully it'll make sense after a while. All right. So again, first step here is just to assign your variables as integers, create odd numbers, then add one to create create even numbers and add one to create odd numbers. Then to prove that the product is odd, I'm going to multiply the two numbers together, FOIL out the brackets, and then just show that this is odd. Right. So the first three terms is even, right? Because you can factor out a 2 plus 1. So even plus 1 will create an odd number. So the product, therefore, is odd. Cool. All right. So I'm going to do another example. And this one here. So it's going to be a fairly similar proof. We want to prove that the sum of the square of an odd number and itself is always even. All right. So a lot of words being here. And it could be a little bit confusing as to what exactly we're trying to prove. All right, so I'm just going to first off show how to kind of break this down. All right. So first thing we want to do is we want to prove that a sum. Okay, so the sum is when you add, okay, of the square of an odd number. Okay, so this is one thing, one of the items that we're going to add. We're going to add it to itself. Right, is always even. This is the conclusion. All right. So so first off, what I'm going to do here is I'm just going to assign the variables. Right, so I'm going to let x be an integer. The reason I don't have to use a y here is because we are squaring an odd number, so a single number, and we are adding it to itself. And so what's actually involved is a single odd number. So if x, we're just going to let x be an integer. So then 2x, so 2 times any integer is even. All right, but in this case, for this proof, it's involving an odd number. So I need to do the next step. So then 2x plus 1 is odd. Okay. Now you may come across some proofs that'll involve even numbers. And if that's the case, you would just stop here. You would just use 2x, right? But once I do 2x plus 1, since this proof is involving an odd number, I have to add the 1. Okay, so some proofs, when you're asked to do a proof of an even number, you would just use 2x. Hopefully that makes sense. All right, so the sum. Okay, so I'm just going to call it S. The sum of the square of the odd number. Okay, so if I take 2x plus 1, and square it, and so that's the first part here. So the sum of this odd number, sorry, the square of the odd number, and I'm going to add that to itself, right? So itself is 2x plus 1. I'll put that in brackets as well. Okay, and we want to show that this thing here is, there's a different pen here. We want to show that this is even. Okay, right there. All right, so yeah, just take a moment, make sure we got everything kind of clear. All right, so again, we want to prove that the sum of the square of an odd number. Okay, so this is the square of an odd number. We're going to take an odd number and square it, and itself. Right, so add it to itself. So again, 2x plus 1. We want to show that this whole thing here is even. So actually, maybe I should. I don't want to just point. Yes. That could be a little misleading. All right, so we want to show that actually we'll do this whole box whole thing. We want to show that this whole thing is even. All right, so how am I going to do that? I am going to basically do what we did in the previous example. I'm going to expand out my brackets. I'm going to collect all of my like terms, and hopefully it will turn out to being even. All right, so again, a little bit of algebra as well. Now, when you have 2x plus 1 squared, basically what we're doing is we're multiplying 2x plus 1 with itself. Okay, so I'm just gonna, you have to write it out twice if you're squaring it. All right, so 2x plus 1 times 2x plus 1. And then to that, I'm going to add, again, it's 2x plus 1. Now, whenever you're adding a algebraic term, you don't actually need the brackets. So I can just leave it as 2x plus 1. All right, so now, yes, I'm going to have to FOIL out the first set here. So first, outside last. All right. So the sum is equal to, okay, 2x times 2x is 4x squared. 2x times 1 is 2x. And then we've got 1 times 2x, which is 2x. And then we have plus 2. Okay, so that's the first set of brackets that are expanded out. Also have plus 2x and plus 1. Okay, so this next line here is basically the brackets expanded out. And I also added it, or at the end there, we have the plus 2x plus 1. All right, cool. And now let's collect our like terms. We have 4x squared, and then 2x plus 2x plus 2x is 6x. And then I got plus 2 plus 1. Oh, sorry, I messed up. My bad. Just realized that this is not 2. See, actually, when you're watching, you might have caught me doing that. 1 times 1 is 1. All right. So collecting those two, that's plus 2. Okay, so this is the expression of what we're talking about here with the expanding it out. Now, to show that it's even, what I'm going to do here is factor out a 2. So I'm left with 2x squared plus 3x plus 1. Oops. All right, so that's a close bracket there. Okay, so 2 times an integer. Right. So this whole thing is still going to be an integer. So 2 times an integer is always even. All right, so now the proof is done. All right, so again, yeah, so this deductive reasoning with these numbers here, it's yeah, it can be a little bit confusing when you first see it. Totally understandable. So perhaps, yeah, just maybe watch these examples over and over again. All right, cool. So that's deductive reasoning, and there's some practice questions in the textbook. Check. All right. So try this out.